Yeah, thanks a lot for joining and thank you for the introduction. We will divide this session into two parts. So the first part will be a pre-recorded video and the second part will be a discussion. So we decided to pre-record the video because it just gives you a smooth experience. It will be mostly a demo, like 80 or 90% demo, 10 to 20% slides. And it also has the advantage that Gerhard and I, we can live answer some of your questions in the chat and the Q&A in Hoover. So we encourage you to ask questions during the presentation in Hoover. And then in the second part, we will have a discussion and would be curious what you think about the talk and about the RabbitMQ alerts. And there's also one part which is missing in the pre-recorded video. So we are curious whether you figured out what it is. And if you do, then we will also show that in the second part. So that having said, let's start the pre-recorded video. Welcome to today's talk. RabbitMQ has a problem. Let us tell you about it.
Just one? I thought there was more than one.
Actually, you're right, Gerhard. There are multiple problems, and we will show you today two of them at least. Many of you have already used RabbitMQ in production, and you really want to feel confident that your RabbitMQ works as expected. And if it doesn't, you want to be notified. And sometimes you can even be notified in advance before things go wrong.
What is that link at the bottom, David?
So you can follow all the examples and all the demos we're doing today.
That's right. So even if you're watching this video after the conference, you can still download those examples. All the code that we use here, you'll find there, including the slides, by the way.
So today we're going to start with a setup. So you just need a Linux host, which can run anywhere. It can be run on some infrastructure provider, like on GCP, or locally on your computer. So let's get started. So I know nothing. How do I get started? So for that, we execute our first make target. And we use K3s, which is a Golang binary containing everything what you need to run Kubernetes. And the only thing you need is a Linux host where you have a public key, SSH key provision. And now we already see that Kubernetes is up and running. So in this case, it just took 13 seconds. And we can double check that the Kubernetes node is up. There we go. It says not ready, now it's ready. And the next step is to set up the RabbitMQ cluster operator and the whole monitoring stack. So there are multiple components involved. We will go over them in a second. But for now, let's trigger the second make target, and then we will analyze a bit further like what we're actually deploying.
The thing which I would like to add here is that even though you could copy paste these commands and you could definitely figure all this stuff out, there's nothing special about it. I mean, all these components are open source. Some of the components we don't build. So for example, Prometheus and Grafana, we just consume the open source projects and the Helm charts and whatever else is there. K3s, it's a very nice and easy way to get started with Kubernetes locally. I know that some of you prefer Minikube. I think that's okay. I'm not sure how well this would work, but it should, with a few differences. And everything that you see here, the RabbitMQ cluster operator, and David will tell us a bit more about it. It's all open source. So we're just assembling them for you in a nice way.
Right. So we open sourced the cluster operator last year. And the cluster operator is just a Kubernetes operator, which defines a custom resource definition, namely the RabbitMQ cluster custom resource definition. So it manages the whole lifecycle of RabbitMQ clusters. You can install the RabbitMQ cluster operator with a single command. That's also what our make target is doing. And after, you use another single command in order to deploy a RabbitMQ cluster. So how does a RabbitMQ cluster custom resource definition look like? So we provided some examples in the docs examples directory on how you can configure a RabbitMQ cluster. One example worth pointing out is the production ready. And if you look into RabbitMQ YAML,
There is another talk that Chuni is giving at the same RabbitMQ Summit, which goes into more detail about the cluster operator and also the topology operator, which is for some maybe even more interesting than this. The point being is that if you do want a Rabbit, this is by far the simplest and quickest way of getting one.
So what else do we deploy in our second make target? So we deploy Prometheus, Grafana, and Alert Manager. So Prometheus is the component which scrapes, reads metrics from RabbitMQ, stores them in an internal time series database, and then also evaluates certain Prometheus rules or alerting rules periodically. And if an alert becomes active and fires, it's sent to Alert Manager. An Alert Manager then can forward the alert again to some backend. In our case, we will configure a Slack backend, so we will get Slack notifications if RabbitMQ has a problem. We also deploy Grafana in order to analyze the problems with our specific RabbitMQ Grafana dashboards. So everything what we deploy here, we can also find them in the same repo under the observability directory in here.
The bottom line is that in a matter of minutes, you can have all this stuff set up. And I know it's just a demo. I think in production, the thing that you need to think about is how do you consume updates? How do you consume the latest of this? So while this is a great starting point, what you really want is something that gets continuously updated, that is validated. And that's where the commercial offering of this comes into play. We won't talk more about that other than it's simple to get started. It gives you a very good idea of what to expect. And then it's the other part, some call it the day two operations, which has a lot of complexity. But even so, the beginning is very smooth.
So we deployed the RabbitMQ cluster operator. And as a next step, we can actually deploy a RabbitMQ cluster. So we are going to deploy a 3-node RabbitMQ cluster. We call it Quick Rabbit.
Nah, it doesn't look right. Less than a second? Okay, I know it was meant to be quick, but not this quick.
Let's investigate what the state is. So we can use K9S, which is a terminal-based UI in order to talk against the Kubernetes API. So you don't have to type the kubectl commands on your own. And here we are in the default namespace, and we see that we just deployed 3 pods, which correspond to the 3-node RabbitMQ cluster. And as we can see, they're stuck in status pending. So ideally, we get a Slack notification. So we haven't got any yet because it takes some time. But for the impatient ones, and the two of us, we are impatient, right? So we click on this link here. We can see that we already have an alert in the Prometheus UI. The first one is no majority of nodes is ready because all of them are currently stuck in pending state. And then we have 3 alerts for persistent volume is missing. And now, in the meantime, there we go. We already see our first Slack alert. And as expected, we see all our 4 alerts, which we just saw in the Prometheus UI. So we can expand it. We see a lot of text and a lot of descriptions. But we also get a clear and concise summary of the problem, 1-sentence summary. So only 0 replicas are ready in the stateful set of RabbitMQ cluster Quick Rabbit in namespace default. And we also have some hints on how to analyze this problem. So we could either kubectl describe the pods in order to see why the pods are not ready. Or instead of copy pasting, we can also use K9S and click D for describe on one of the pods. We jump to the very end, and then we see already, okay, that we have insufficient memory.
T, who put T so close to the G, right? 1 terabyte. That is a lot of memory. Maybe genuine, but this host does not have a terabyte of memory.
So let's fix that. So in order to fix the problem, we just substitute 1 terabyte with 1 gigabyte. So now every pod is requesting just 1 GB of memory.
And that's exactly what we intended for sure.
Cool. So all the pods are now up and running. And if we refresh the Prometheus UI, then we see already that the alerts got resolved. So we would also expect that they are getting resolved in Slack, and there we go. So the alerts already got resolved, and our first problem is fixed. And the second problem will be about running out of disk space. So many of you have experienced this already. Over time, the disk might fill up, especially if your publishers are publishing at a higher rate than consumers are consuming. So it's okay that your disk is maybe half full at some point in time, as long as your consumers consume messages again. However, if there is a trend over some past time frame that your disk continuously fills up, then you might want to be notified about that.
I think this is a fairly common problem, right? So first of all, configuration errors, that is possibly the most common one. Misconfigured clients, poorly written clients, all sorts of problems on that end. A misconfigured Rabbit, that happens quite a bit. And then the next one is just running out of disk space. Because there's no limits set on Rabbit. Like the queue can fill up to infinity. And we know that doesn't work because there's no such disk size. And in this case, you would want to know when this is a problem in the making. I think that's like the really nice twist. I mean, you can see what's happening over maybe, I don't know, 24 hours, maybe longer. 24 hours is a good default. So based on the activity from the last 24 hours, we could estimate that, hey, you may run out of disk space if this trend continues. And I think that can really help in some cases.
So in order to simulate running out of disk space, we have another make target, make second problem. And it will deploy perf test, which is a RabbitMQ client.
Can we see perf test in K9s? There it is. That's our perf test client. Okay. And if you press L for logs, what does it do? Okay. So we can see how many messages we're sending, confirming, and how many messages we're receiving. Okay. So yeah, I mean, if this doesn't stop, then obviously your consumers will never catch up. And RabbitMQ will fill up, and you may run out of disk space if you don't have a limits configured.
So in the meantime, let's get a different perspective on the problem. So we can open up the RabbitMQ overview dashboard in Grafana. And here we see already that right now we have about 37 or 38,000 messages being ready to deliver to consumers.
Yeah, I mean, they're just waiting to be consumed and they're just growing. So I think if you scroll down, we can see, there you go, we can see the first one, the queued messages ready to be delivered to consumers. We can see how that's growing and it's approaching the limit of 50,000, which is when it will start dropping old messages.
So if we look into Prometheus again and refresh, we already get our second alert, which is low disk watermark being predicted. So we also put some descriptions into the alerts and what you can do to remedy this problem. So there are some links to more documentation to understand the problem.
So when there is a problem, as is the case here, we link to the parts of the docs which are most relevant for you. So for example, we go in alarms, we go into disk alarms, we go into, specific things. And while it's not the quickest way of fixing your problem, at least it's the best way of understanding what is happening, why it's happening, what you can do about it, because you have all those options. And, you may choose, for example, to grow the disks, or you may choose to add more consumers, or maybe you just want to limit how many messages a queue is able to hold. That is also possible. And there's no one approach that is best. It just depends for your context, for your scenario. And that's why having all these options and being aware of what the options are sometimes helps.
So by now we reached the maximum queue size of 50,000 messages. So now that's the point where the old messages, as Gerhard mentioned earlier, are getting dropped. So there can never be more than 50,000 messages in the queue because each message has a size of 10 kilobyte, and we configured the max disk size to be 500 megabyte for this queue. All right, so we got an alert, but how can we fix that problem?
It would be nice, to be honest, for some problems to be automatically taken care of, like this one, for example, but it's difficult because sometimes you don't know what the right answer is. I mean, do you want to grow the disks? Do you want to add more? I mean, can you add more consumers? We wouldn't know. Maybe those consumers are using a backend system, and the backend system is the bottleneck. So adding more consumers is not going to speed things up. A lot of the time, it just depends, right? I know that people don't like hearing that because it's like an overused term, but in this case, it really depends. And it's also about what you want to do, right? Because sometimes, I mean, you may think, well, for this queue, this is the right approach, but for another queue or another cluster, there's a different approach. There's that. There's no one solution applicable to even like your queues, never mind everybody else's.
Yeah, so as Gerd mentioned, one potential fix would be to increase the disk size, and that's actually a feature of the cluster operator. So we can increase the persistent volume. Yeah, Chuni implemented that feature, so thank you.
And it's very smart, actually. It does like a couple of very smart things behind the scenes. It wasn't as trivial, like some specific challenges to the implementation, but Chuni navigated really nicely, I have to say. It's one more reason to use the cluster operator. There's like many, I would say, subtle features that are really difficult to just like maybe list them all. There's like so many things that it does. But if you attend Chuni's talk, she will talk more about the operator, the cluster operator, the topology operator, and maybe she will mention this, but it's her idea and her implementation. It works really well. We tried it and it's great. We can resize disks on the fly with minimal downtime, and it just works. So that's great.
Yeah. In our case, we are adding more consumers. So we have another make target. Resolve second problem. So we would expect that the disk space starts to increase again, and there we go. So at the bottom, we were around like 39 gigabyte. And since we added more consumers, it quickly increased again. So the number of ready messages will also drop drastically. And we can already see that disk space got reclaimed. So we would expect that our alert is now resolved, which indeed is the case. And also in Slack, we see that the load disk watermark predicted alert is being resolved.
That's great. I mean, imagine how long it would take you to figure out what the problem is if you don't have the dashboards. And also if you don't have things working together so well. So it's not just about the monitoring, but it's also something that watches those metrics and that alerts based on those metrics. And that's exactly what we have here. So never mind, we have a lot of metrics which work reliably. Watch our talk from 2019 to see why that wasn't the case before. So we have reliable metrics, accurate metrics, fast metrics, and we now also have alerts for those metrics. So we're making use of what we did in previous years. Okay, what's next, David?
Right. So next we can check out how we can see problems of the past. So we built a new dashboard for the RabbitMQ alerts. This one here. So you can filter by namespace, RabbitMQ cluster. Right now we just have a single one deployed, and also by alert name. And you see an overview of your current alerts. So how many are firing, how many are pending. You see a table list of your past alerts, and you see a status map panel of all your alerts in the past. So the first two problems introduce the persistent volume missing alert, the no majority of nodes ready, and the low disk watermark predicted. And green means there was no problem at all. Orange means it's pending, and after a while, an alert switches from pending to firing, which would be depicted by the red color in here. Then we already saw the Prometheus UI, but we only saw pending and firing alerts so far. So if you look at the inactive alerts, then we will see all Prometheus rules we wrote for RabbitMQ. And the first one is actually for the RabbitMQ cluster operator itself. So that's not for RabbitMQ, but for the operator which deploys the RabbitMQ clusters. So, for example, if the operator is unavailable, we will get an alert. Yep, so we already saw the Grafana dashboards, the Prometheus UI, and now we see also the Alert Manager UI. And right now we don't have any active alerts. That's why we can't see anything in here. But yeah, Alert Manager is the component which receives alerts from Prometheus. And then it forwards, in our case, alerts to our Slack channel. However, you can also configure different backends for Alert Manager. So you might want to add a backend to add PagerDuty, or another backend which sends an alert to some webhook URL.
One point which I would like to make is that all these components, we haven't developed them. So it's not something that we maintain. It's not something that we have to worry about. We just consume them.
So as Gerd mentioned, we just integrate what's already there for us, and the value we add on top of it are the RabbitMQ specific logic, which we encode in our case, Prometheus rules. Okay, so we have popular dashboards for Grafana. So we saw already the RabbitMQ overview dashboards. We saw the RabbitMQ alerts dashboard. There's also the Erlang distribution dashboard, which gives deeper insights into metrics of the Erlang VM itself. So that's not necessarily RabbitMQ related, but more one level deeper. So that goes to Erlang.
Erlang memory allocators, I think that's my favorite, because I mean, we have been talking about RabbitMQ memory for such a long time, for many, many years. We've been shipping all sorts of improvements. Erlang itself has been shipping many improvements. And this is possibly the neatest graph that you can have.
Yeah, we also wrote a blog post about RabbitMQ alerting. So basically it summarizes somewhat the talk we are giving right now. And this one basically sets up everything for you to get you started. It describes all the alerts which we published. And if you don't like makefiles, that's okay too, because we have a bash script which sets the observability stack up for you. We also have TGR. So these are RabbitMQ specific videos on various topics, whatever was asked for by the community. So I found secure public RabbitMQ clusters very interesting, because that's a very common problem which many people face in production. And so it taught me how to use traffic, for example, and how to use TLS from your clients up until your RabbitMQ cluster through a load balancer in the EAS.
Also, there's a repo. So all these talks are in the github.com RabbitMQ TGIR. So all the code that we used for these episodes, season 1, episode 8 was secure public. There you go. And yeah, everything we have, cert manager, we even give versions and whatnot, and it's all there. So if you're interested, that's a good one to look into.
So we showed you how you get notified is if RabbitMQ has a problem, or if there's a problem in the making. We think it's very easy to set up compared to any approaches we had in the past, like in the past years. And we would like to encourage you to also try it out and give us feedback on any alerts which are missing, or we would also be interested in whether the alerts work for you for your production systems.
Yeah, that's actually a good point, because we have been asking, we have been showing these alerts like to various users, and we already have a couple which we know are missing and we know we have to add, but we're also wondering, is there anything else that you are missing? Also, from our perspective, we obviously would say it's easy to use this, but is it? If you try it, how easy was it for you to actually use it? And the more diverse perspectives, the more different the perspectives, the more useful they will be. You may say, you know what? I don't want to use Kubernetes. Okay, so then what else would you be using? Because I'm pretty sure that approaches like these exist out there, but they may be a little bit different, and we would like to learn from them. We would like to see what works in that case, what doesn't work, and how can we maybe bridge the gap between what we have and what we are proposing here versus what you already have and you've been using for maybe a few years. We don't know. Now we go to the really good part. Okay, the RabbitMQ 3.9. So I think there will be a few talks about RabbitMQ 3.9 at the summit, but we'll introduce two specific features. What is this JSON logging?
Right, starting in RabbitMQ 3.9, RabbitMQ can output JSON logs. So we have another make target which demonstrates this, which is the bonus. So we will install Loki, which is a logging backend which integrates with Grafana. And we are going to install also Promptail, which is an agent running on every Kubernetes node, shipping logs from the Kubernetes node to Loki.
Right, so Loki, you can think of it as like Prometheus, but for logs.
We can look at one example of a logql query that we are going to use. If there is a RabbitMQ crash, we are going to be notified about this. So this type of alert is very different from what we saw earlier on. So earlier on, we got alerts from metrics, which were stored in Prometheus. Now we are going to get an alert based on logs, which come from Loki. And as you can see, JSON logging enables us to write a very simple query. So we just query for all logs with a label called RabbitMQ, pass it to a JSON tool, and then we just query for logger type crash report. And we will see in a second how this will be formatted in a Slack notification if a process in RabbitMQ is about to crash.
Okay, so we have the new JSON RabbitMQ server starting now. That is our RabbitMQ node configured with JSON logging. Can we, if you press L for logs, there you go. So these logs look significantly different.
Yeah, Jean-Sébastien was introducing JSON logging and made everything configurable for you.
That's very nice. Thank you, JSP.
Okay, so in the meantime, Loki and Promptail and the single node RabbitMQ cluster outputting JSON logs got deployed. So now we can check how it looks like in Grafana. So in Grafana, there's the Explore tab. If we select Loki as a data source and open the log browser, search for all components with the name RabbitMQ, and then choose our JSON Rabbit pod, then we see already the JSON logs in Grafana. So if we crash a RabbitMQ process, then we will expect to get a Slack notification.
Yeah, and this is a pretty hard crash. So this is not where we crash an Erlang process. So it's Rabbit metrics. That's a very important one. It's not a transient failure. If there is such a crash, it takes down the entire Erlang VM, including the container. So that gets restarted. And that's what we would see the restarts, right? They would go up, but not just that, we'd also see a crash.
Yeah, so we can see the restart here.
Mm-hmm.
And if you open Slack, then we see already that we got an alert for the RabbitMQ crash. So we get a stack trace. And the point here is you don't need to understand the stack trace right now, or maybe it doesn't even make sense to get an alert based on a RabbitMQ crash, because some crashes are actually expected. Maybe not this one, but some crash reports are expected in RabbitMQ, and the supervisor will restart the process. But the point here is we want to show you how easy it is to configure a alert based on JSON logs. So this opens the floor for question and answers. And actually, Gerhard and I, we prepared 2 questions which we are having. So these are the first 2. Like the first one is, are the existing alerts helpful to you? And the second one is, what alerts are you missing? And in the past, we have been asked questions 3 and 4. Like, first of all, how to add custom alerts, how to add new alerts, which are specific to RabbitMQ clusters users are running. And the fourth one is, what is the most common RabbitMQ problem like we have experienced during our time in the RabbitMQ team? Welcome.
Thank you.
Thank you.
How much time do we have for questions?
We have about 5 minutes for additional questions here. And so everyone, please turn on your camera and ask your questions. And while you do that, we can say that there's already been a few questions, like, is it possible to have things that auto heals the cluster once something has happened?
Yeah, so that's a good one. It's something which we're thinking about, definitely. So some alerts, like, of course, you'd want to fix them. Now, others aren't as straightforward. So first of all, which are the definite alerts that you would want to fix? What are they? From the list of the 10 that we have, which would you expect to be automatically fixed? And what would a fix look like? That's a question that we would ask. So yes, we're thinking about it, but it's complicated.
Yeah, so for example, for the second example which you showed, where the disk is running out of space, you could have the operator, for example, do the work of auto increasing the persistent volumes. But then the question is it always a good idea? Or is just adding more consumers the solution? So it depends. It's difficult to auto heal certain things. It depends on the scenario, but we are planning to add that functionality to the cluster operator where it makes sense.
Now, here's a crazy idea. What if a queue and the clients are running on a cluster which is overloaded? Would you like to move the queue to a cluster which can handle the load? That's interesting, isn't it? Now, that's the type of healing that people really want, right? They just want their workloads to migrate automatically, but that's really hard. Worth it, but hard.
One question there that I would be very interested in is, what is the most common issue? And I mean, we will bring this up in our talk tomorrow, both like what's the most non-critical, or what are some really scary and things that don't happen very often, but then also what's the most common. So I would be very happy to hear from the audience what they think is the most common issue.
Yeah, I guess I will do. So I guess producers outpacing consumers, and then manager problems when network splits. And so yeah, the new metadata storage is a good thing here. So yeah, for me it's mostly these two, because based on measure you can't easily scale out, right? You have to think about measure essentially, not your kind of domain, but about measure. That's interesting. Yeah.
I agree. I would say that probably a very common issue is that people forget about the RabbitMQ because it runs so well that it's forgotten. The person that was setting it up in the beginning leaves the company, goes somewhere else, and then something happens and you don't have a playbook for what happens.
You mentioned a very magical keyword, playbooks. Playbooks are, I'm thinking about runbooks when you say playbooks. When there's a problem, what are the steps that you would follow to remedy the problem? And if anything, that in a way would come even before automating those runbooks. Step 1, step 2, step 3. How do you fix things? Like, I think we had a question somewhere, I forget where, I think it was like a community topic in Hoover. The question was around high CPU and high memory. So what do you do when your RabbitMQ cluster has a high CPU usage, high memory usage? How do you fix that? Now, obviously, you can take many fixes, but maybe if we knew more about what the actual problem was, maybe it's too many messages. Maybe it's connections that keep churning, but maybe the connections aren't being closed and you just keep opening new connections or new channels, whatever the case may be. Or you create new queues. Again, we don't know. So based on that, if we knew better what the problem was, we could recommend a set of steps to follow that are maybe closer to remedy the problem. And I think that's where these come in. So first of all, what are like all the failure modes? How do we detect them? And obviously that's like, it will take forever. What are the most common ones that most people, and that's why that is a very good question for us, because we would know what to focus on. Now, a bunch of these, right, are already free, like 10 alerts. You can set them up, you can modify them, you can add more. It's in the spirit of open source. They're all out there. The dashboards are open source. So I would be interested in how would you add them, and would you add them? Like, would you use this sort of setup? Would you use Prometheus? Would you use Grafana, or would you use something else? Or do you use something else? That's where you come in. That's only people here can answer that question, and obviously that aren't part of this talk, because we don't know. And there's no wrong answers, by the way. It's whatever you use.